My name is Miles Harrison. I'm the President and Chief Executive Officer of Conexeu Sciences. My background is essentially healthcare all my career. I started in Novartis, spent several years there across different geographies. More recently, in Galderma, I was the North American President of Galderma from 2016 till 2021. So high growth time for us. We had three verticals. One was aesthetics, one was prescription, and the other a consumer division. The brands like Cetaphil, which your subscribers and listeners would probably know very well here in the US, as well as a global brand. After I left the Galderma business, I did my own startup and imported two hyaluronic acid injectables. They're known as Safe for Chic and Safe for Magic. Both of Magic is, actually both have now been approved by the FDA, and they're under the Obagi brand. And that's through an acquisition actually in July of 2025, where the company was bought by Waldencast out of the UK. So a public company. After that, I thought about different career options, and one of our board members, who is a plastic surgeon in Manhattan, pointed me towards Conexeu Sciences and told me, look, you love disruptive technology, and I know you work with strong teams, you should take a look. And so hence I'm here as of November of last year, leading this company.
I'm Brian Pilcher. I am the Chief Medical Officer for Conexeu, and I am a cellular molecular biologist by training, having gotten started in wound healing. So I've always been sort of grounded in dermatology. I did my postdoctoral fellowship in derm at Washington University in St. Louis. Spent a couple of years in academics, but then joined a really small startup dermatology topical company that made an anti-inflammatory cosmeceutical now under the SkinMedica line, actually. But I was acquired from that company by another startup company called Bioform Medical, and you probably know them as the original makers and distributors of Radiesse, a biostimulator dermal filler. So I've actually spent my entire professional career, even though I'm a wound healing biologist, I've spent it in injectables. So dermal fillers, neurotoxins. Bioform Medical was acquired by Merz in 2010. I stayed on board with them as head of their global medical team, just in medical dermatology, as well as the injectable aesthetics franchise and neurology, and left at the end of 17. In 18, I joined Suniva Medical, another company in the dermal filler space with a longer lasting biostimulator. And they were acquired by Tiger Aesthetics in 2024. And much like Miles, the same plastic surgeon friend in Manhattan exactly said the same thing to me. You should look at this technology. It's very innovative, potentially disruptive, and in a category of dermal fillers that really hasn't seen a lot of innovation over the past 20 years. When I saw the basic science behind this product, which is backstopped in wound care, a lot of data behind that, it seemed that it may have an interesting role in tissue regeneration. And that's, I'm sure, as you know, a hot topic in today's medical aesthetics field. And some of the recent data that we're going to talk about on this interview really makes us excited at the potential opportunity of this material, this technology in the medical aesthetic space. So I was happy to join full-time with Conexeu at the same time that Miles did, and we're progressing forward.
That's a great question. So thank you for that. Before I get there, a little bit more about Conexeu. So we're developing a bio-regenerative tissue platform. So it's designed to restore this extracellular matrix, which is the structural foundation required for tissue regeneration. So what we believe is, and what we're seeing is the convergence of regenerative medicine. We see volume loss, contouring opportunities, but GLP-1 has sort of shown that volume loss more recently. Wound repair and reconstructive medicine creates this significant opportunity in what we believe there is a new category focused on tissue restoration. So when we think about traditional fillers and other methods for treating patients, first of all, the GLP-1 category is creating one of the most significant shifts we've ever seen in aesthetics over the last decade, and one of the most significant shifts in healthcare. So if we think about the US, just the US, 1 in 8 US adults reports using a prescription weight loss medication. As you probably know, and as some of those who are listening to this, you can get it relatively easy. You can use telemedicine, and your product can be in your mailbox within a week or two, and for actually a fraction of the original cost. And so this market, because of the openness to access, because we've gone from one company to multiple companies, we've gone from an injectable to a tablet, and we've gone from patent protected to now in Canada, for example, it's generic. So it's just starting to move there. Pricing has shifted, access has shifted, and the market is estimated by McKinsey to be about 200 billion by 2030. And as more of these patients experience this rapid and substantial weight loss, clinicians and injectors are thinking about how to encounter this facial hollowing, the skin laxity, and this soft sort of tissue deflation, and these overall changes. Now, the challenge is that most current injectables, and I would say hyaluronic acid based, as well as our biostims, of which there are 3 here in the US. They're primarily designed for contour enhancement or wrinkle correction, and it's really small volume facial augmentation. So you can see that when you look at the label. So the label is per milliliter per kilogram per body per year. So they were not addressed for the larger scale tissue defects and deficiencies that you see. So what many people call Ozempic Face is not simply a volume problem, and it's actually not a cosmetic issue. It's also a tissue quality problem, and this rapid weight loss, where you deplete the adipose tissue and accelerate the degradation of the extracellular matrix, acts as the structural foundation and framework that supports the healthy tissue, and that's what we want to help regenerate. So this is where regenerative medicine becomes very important. And this is about the science of restoring, replacing, or regenerating human tissue. But what we also can do is add the volume that's required. And Conexeu, we refer this to as bioregeneration, which is restoring the overall biological framework to allow that tissue to rebuild itself. So I'd say, back to your question, unlike the traditional fillers that primarily occupy space, our product is being developed as a thermosensitive extracellular matrix that's intended to support the body's natural regenerative process. Think of it like a blueprint. And we believe the future opportunity is something as simple as that. It's giving your body the blueprint for tissue restoration rather than simple volume replacement. And our data is showing that this is there's a huge tailwind, highly valuable opportunity for aesthetics patients, for dermatologists, for plastic surgeons, in an industry, as I said, that is $200 billion in prescription, and an emerging category that Boston Consulting Group have put a number on of around $2 billion by 2030.
There's obvious interest from the provider standpoint because they're seeing this massive influx of new patients into their practice that have been on GLP-1s. They've gotten the desired result, right? They've lost a lot of weight, but now they're having this gaunt appearance. You hear the term Ozempic face, that's sort of been coined. And the providers don't have a lot of tools. They have a lot of tools that they can utilize, but all of the discussions that you're seeing, whether that be at the conferences or in the journals, is, okay, what are the combination therapies that I need to use in order to help replace that volume? And one place that we see from our standpoint at Conexeu, sort of blue sky or green grass field, is the opportunity for a truly regenerative material to come in to provide for that larger volume tissue restoration naturally, right? That's going to be an important part to do it naturally, because there's also this massive swing towards more natural, clean beauty in the industry happening at the same time. One thing that we at Conexeu also desire to do is sort of be a leader in defining what tissue regeneration is. It's actually not a new term. It's been very well defined historically, but I think our space, especially medical aesthetics, is kind of struggling a little bit with it because the marketing is a little bit ahead of the science in this particular space. So if you go to the AAD or you go to MCAS, for example, in Paris last year, it seemed that every single company has begun utilizing tissue regeneration as a marketing term for their materials that or products or technologies that are actually quite old. They're looking at one particular piece, whether that be simply collagen regeneration or utilization of an exosome to generate something within that tissue. But we want to look at it holistically in the company. And so the way we define it is actually quite simple. You just need three building blocks. You need cells, which are the worker bees. They're the ones that are actually producing new tissue. You need some form of biological signal, growth factor or otherwise, that's going to stimulate them to produce new tissue. And then you need that structural foundation upon which the tissue is built. And so what we're trying to do is replace what's been lost in the extracellular matrix or that structural foundation. That's the way we view it. So we're solely in that number three of what I just told you. And the scaffold is very important because if you think about wound healing, for example, Mohs surgery would be a very good example where you have an excision, of a skin cancer. You're actually removing a big clump of tissue and you're removing that extracellular matrix component as well. And so if you can replace that very quickly, get 100% wound coverage quickly and integration, you can have a chance to increase the rates of healing and get better cosmetic outcomes. And because of our thermosensitive nature, I'll describe in just a moment, briefly, that we believe that's going to be an interesting play on the wound healing front. In addition, aging, as a progressive result of time, everyone knows that you get breakdown of the skin envelope. The extracellular matrix is broken down as the cells switch from a matrix productive to a matrix destructive phenotype. And in addition to that, you have, resorption of the fat pads in the face and then that lost volume. So combining that with the GLP-1 market that we just talked about, restoration of that extracellular matrix when it's been broken down or it's been completely removed, as I just mentioned, is we believe is going to play a significant role in the tissue regeneration story. So now I just want to very briefly talk about what we mean by thermosensitive. This product is envisioned to be lyophilized or in powder form in a vial at the bedside, so you can reconstitute it much like you do your neurotoxin or your polyl-lactic acid. So it's going to fit very easily into the practice flow. When you reconstitute it at room temperature, it actually flows as a liquid. So it's not a gel at room temperature, it's a liquid. And that allows you then to administer it via syringe with a fine gauge needle. So the things that are very important to the patient, right? Less pain, less bruising and swelling, that type of thought. We believe that it's going to fit very well within that practice flow. Interestingly, however, whenever you apply it into the tissue bed or you apply it to the human body, at 37 degrees, it begins to gel within 10 minutes. So it begins to gel from the outside in. It fixes it in place. It doesn't, splay into the surrounding tissue planes, which means it's going to be there and integrate very easily into the tissue. And that then provides that extracellular matrix that we're talking about that the surrounding cells can then remodel and migrate in and lay down new tissue. So that's basically how the technology works. That's the idea behind it. And the proof study that you're talking about, which we have just recently completed, it was a 12-month study. It was meant to basically establish three things. And it's in two compartments we injected, both in small volume intradermally, as well as large volume in the subcutaneous space. We wanted to understand what the tissue response was going to be in comparison to known dermal fillers on the market. And the reason why that's important is, there's already established table stakes that you need to meet as a injectable dermal filler. I talked about it, how you can reconstitute it easily. It goes through a fine gauge needle. That's the type of practice flow pieces that are very important for providers. But more importantly, what is the tissue response? What is the inflammatory response? What kind of tissue ingrowth do you have? What is the persistence of the material? And how is that remodeled over time? Not simply from an interest from a scientific perspective, but also from a regulatory perspective, because we also know that the FDA has become much more interested in companies being able to demonstrate with these new technologies the ability of that material that's been injected to resorb over time. So you're reaching steady state within the tissue. Whether or not you're having an initial inflammatory response or a more long-lived inflammatory response, the FDA would like to see lower inflammatory profiles with new products that are coming onto the market. So these are all of the things that we've looked at within this particular study. In addition, we also have determined the mechanical performance of this particular technology within the tissue, because when you inject these materials, you want to have immediate volumization and you want to maintain that volume over time. So looking at the rheology, for example, of these fillers and comparing it to the already established benchmarks that are state of the art in the industry. So those are the things that we've looked at. We're very pleased by the data. We're not publicly releasing the actual details of the data yet because we're going to get it submitted as an abstract for podium presentation and subsequent peer review. But we're very excited by the early signs of this data as we found it so far.
Maybe, Brian, I can just add that this is a company that's not new to the space in terms of the foundation of the science, because this CXU, as we're calling our product, originated from more than 10 years of research at the University of British Columbia and is supported by international patent ownership and has generated 11 peer-reviewed publications which span regenerative medicine, wound healing, tissue engineering, transplantation, and dermatology. So we have got the experience and we have seen the science in practice, and those publications are available on the website.